Hi everyone, hope you're having a great day. My name is Wan Wing Jiang, representing Group 12 of our Measurements and Instrumentation project, which is Digital Signal Processing, or also known as DSP, through Fast Fourier Transform, FFT, which is being spearheaded by our lecturers Prof. Madhya IR, Dr. Rizaldin bin Ramli, and Encik Muhammad Faisal bin Mat Tahir. So according to the fundamentals of digital signal processing, this mini article made by David R. Rockman, it is said that digital signal processing converts signal from real-world sources, usually in the form of analog, into digital data that can be analyzed. Analysis is performed in digital form because once a signal has been reduced to numbers, its components can be isolated and manipulated in more detail than in analog form. When the DSP has finished its work, the digital data can be turned back into an analog signal with improved quality. A DSP can filter noise from a signal, amplify frequencies, and suppress others. So, in this problem-based learning project, we are required to understand how digital signal processing is achieved, and it is achieved through Fast Fourier Transform. Fast Fourier Transform, or FFT, allows us to convert a sounds graph in the time domain to a frequency domain, giving us the opportunity to analyze what will be considered complex sound waves. We have acquired 3 different sound files, where for this case we've used 3 different doorbell sounds, and to transform each of them from time to frequency domain graphs using MATLAB codes as shown in the following images. As we can observe from the code, it is being split into 2 parts. One being the code to produce the graph in the time domain, second being the code to produce the graph in the frequency domain. In the first code, we implement the function audioRead, which reads out our intended .wav file, and we use y and fs as our variables that were set for the purpose of getting the desired sample length and frequency of the graph. Test is where we place our .wav file in the code. Moving on, to produce the boundaries of the graph, we use linspace as the function to do so. And then after setting the variables, we plot the graph using the plot function. In the second code, we set the length of the Fast Fourier Transform, set the Fast Fourier Transform to our sample in 1024 units, and plot our frequency graph. The 3 sounds that we have used are as follows. So after implementing the sounds into our code, we get the following results for both time and frequency domains. In conclusion, our group have successfully understood how DSP is achieved using a computer software like MATLAB. It is done through the use of codes that have the Fast Fourier Transform function that allows for conversion of time domain graphs to frequency domain graphs. From this, we can see that there are some slight differences in between each of the doorbell sounds, as they are obviously not identical. But more importantly, the pattern produced in each graph, be it in time domain or frequency domain, show their respective differences. So this concludes our video for today. We thank you all for viewing our video, and we hope that you learned something out of it. If you enjoyed the video, please leave a thumbs up. If you have any comments, do leave it in the comment section below, and have a great day.